Hello and welcome back to another episode of POMODEV. So I had a little bit more time today, so I thought to record some episode in advance, and especially because we were at basically a middle point of the documentation, and it was a little bit sad to leave it like that. So without further ado, let's start right now, and let's see where we were last time. So we just finished to implement a test script about how functions and variables work, and this one was about rotation. So we had to rotate our sprite, and now by moving forward we have another parameter. So now we can also we'll see how to move our sprites basically. So we have this script here. So we have we are not using our speed, are we? Am I missing something? Let me check. Every node instance with the script attached to it will have its own copy of the speed. Okay, but are we using it in some context? Yeah, okay, didn't just notice. So we add a new var. Yeah, do I need to add it to the process? Yeah, inside the process. So we are declaring a variable inside the process, and it's a vector2 up rotated rotation times speed. Okay, let's see what this is about. So we define a local variable named velocity, a 2D vector representing both a direction and a speed. To make the node move forward, we start from the vector2's class constant vector2 up, a vector pointing up, and rotate it by calling the vector2 method rotated. This expression is a vector pointing forward relative to our icon, multiplied by our speed property. It gives us the velocity we can use to move the node forward. We add velocity times delta to the node's position to move it. The position itself is of type vector2, a built-in type in Godot representing a 2D vector. Okay, so let's just do that. Let's do var velocity equals vector2 up. Okay, and I can see what this is about. Let's see if I can find the constant. Okay, up unit vector, y is down into this, so this vector points. Okay, so basically these are presets. I think it is the same thing as doing like 0 and -1 like this. Okay, got it. So up and then rotated in rotation direction, and then we take, let's see if I can find the property. Yeah, you see, no, it's not called speed, it's called position. Okay, so we have the node 2D position here, and can I see? Why it goes so far down? I open the documentation. Okay, position. Default vector to, yeah, it's right. So the position is a vector. So if I pass to the position of the sprite the velocity, it will sum up the two vectors, so velocity, and we also add a delta. In this case, I don't understand quite well what kind of value delta is. It is a vector, or it just like multiplies the velocity information to everything of the vector to delta. I believe in the latter. But anyway, let's see what is the Uh, okay, maybe I just missed something. So we have our velocity, we have our position. Yeah, that's the main problem. I'm just doing a mess right now. I need to take it out of the main, maybe. No, okay. So what am I missing? Let's just remove this stuff right here for the moment. What am I missing? Did I just... Let me check something. Yeah, it's plus. So we define the velocity. We take this function with the... Oh, I didn't multiply by speed. That was my mistake. So we take... This is to place the vector in a certain position, and then we multiply it by the speed, in this case 200. So now it should work. Yeah. Look at it go. Very good. I mean, I can... What if I diminish the speed? What happens? Yeah, okay. It goes a little bit slower. Alright. We kinda get something. Our node currently moves by itself. The next part, listening to player input, we will use the player control. Okay. Moving a node like that does not take into account colliding with walls on the floor, and that's really, really bad for us. In your first 2D game, we will learn another approach to moving object when detecting collision. Okay, so basically it's telling us, forget everything you just learned. But this maybe could be helpful for other things. Maybe, you know, moving UI, moving... The principle, I think, is the same. The position is a vector, and we add the velocity. We add the... Yeah, the position, the direction is a vector, and then we, based on the speed, we move it around like this. Okay, got it. And this is the complete script. But I think it's quite... I think it's but yeah. Sorry, I blanked out for a second. I was going to say I think this is understandable enough. I sometimes getting lost in trying to translate things. Okay, here we are listening to player input. So I remember I was looking to Brake's video, and there was something relating to getting, yeah, to configure like the action in a certain part of the editor. So you have two main tools to process the player input in Godot. The built-in callbacks, mainly unhandled input. Okay, the built-in input callbacks, mainly unhandled input. Like process, it's a built-in virtual function that Godot calls every time the player presses a key. It's the tool you want to use to react to events that don't happen every frame, like pressing space to jump. To learn more about input callbacks, using input event. In which section are we? In the manual. Okay, let's keep this in mind. It will come useful later. The input singleton. A singleton is a globally accessible object. Godot provides access to several in scripts. It's the right tool to check out the input every frame. So this for stuff that happens not every frame, and this for stuff that happens every frame. If we're going to use the input singleton here, as we need to know if the player wants to turn or move every frame. Do we? Okay, I believe. For turning, we should use a new variable, direction. In our process function, replace the rotation plus angular speed times delta with the code below. So we need to replace these. Let's just comment it out. And let's see. No, I don't need an emoji. So var direction equals 0. And I need to declare it inside the process. It seems so. If input is action pressed, UI left, direction -1. If input is action pressed, UI right, direction 1. Rotation is angular speed times direction times delta. Basically this, yeah. So it won't rotate if there is no direction because it's times 0. And this gives the negative or positive sign to the rotation. Okay, so let's try that. Var direction equals 0 if input is action pressed. And let's take UI left. I guess I need to put this here. Direction equals 1. No, -1. And then we do the same, but with UI right and direction equals 1. And so we need to change this one here to like this. So we comment it again. And now it should accept, yeah, direction from the user. This is kinda giving me ideas for other games, but now it's not the time. I need to focus on learning this stuff so that I can implement it in my game correctly. So what I know is that inside the project settings there is the input map. So I can add a new action here, like rotate left and rotate right, and then I think assign arrow. No. Oh, okay. I understand. So I just for rotate left I will do this, and for rotate right I will do this. And now I think I can use it here as well. So rotate left and rotate right. Let's see. Yeah, exactly. It works as intended. So I guess this is something that I already got it from previous tutorials and videos that I watched. Okay. Let's continue. Our direction, yeah. That is what I got from the code. We use condition as the use of input. A condition starts with the if keyword. To check if a key was pressed this frame, we call input is action pressed. This may detect a text string representing input action returns true or false otherwise. These are predefined in Godot project. You can see an edit input actions exactly. That is what we have done. We use the direction as a multiplier. Yeah. Okay, that was the code about. So I think was very clear. Moving when pressing up. Okay, this will be our acceleration. So var velocity equals vector 0. And then this will be replacing these, basically. So this is direction and this is acceleration. So we do not assign the vector straight up, we just assign it when the input is pressed. So basically var velocity equals vector to 0, that I imagine this is the same by doing this. It's just a shortcut. And then we indent because we need to do this. And in the case I will just leave UI up. Sorry. Okay, let's see if it works. Yeah, I think. Yeah, this works flawlessly. I think we're getting closer to. Oh my god, what is that? I think we're getting close to what we need for our game. So velocity, even though was explained is that we need another method for moving, I hope that we will see what it is really soon. This is the complete script, and this is our sprite moving. Okay, so every script in Godot represents a class and extends one of the engine built-in classes. The node types your class is inherit from give you access to properties such as rotation and position. Since we have so direction is something that we have made, but position, where am I looking at? Sorry, I was saying no. So angular speed and speed we have defined. Rotation is a property. I cannot oh, I see now. I see these here and these here are different colors. Okay, I've noticed every kind of color here, but this is very, very sudden. How can I say? It's very. There is a very light difference between these and these. Let's see if I can change something about it, because it would be very helpful if I can understand what is a property and what is not. Text editor, theme. Okay, symbol. Doc comment user type engine. Is it this? No, this is not the. Is it a symbol? If I do it like this, does it? No, it is. Okay, it is this thing. No, the symbol is okay for this. I want to change the property. Selection, brace, current, number, function, mark, bookmark, breakpoint. Okay, GD script. Function, global node reference, annotation, string name. Is there no reference for this? Member variable. Okay, maybe it's this. Yeah, okay. So, I think this color, because if I go too low, it doesn't, no. Let's see. Maybe I can just change the hue a little bit. It seems I can make it like kind of purplish, maybe. So what if I just rotate it a little bit like this? No, it became an if. Okay, I will see what I can do. Now I won't lose time to this. But okay, so we have some grasps now for what actually works for movement and so on. But the premise that we have to forget everything we know because we need collision, it's kind of scary. But at least we have now completed the listening to player inputs. We now have using signals as a final step. So, signals. From what I have understood, signals are literally signals. So nodes that when doing stuff will emit a signal that other nodes can listen to and act accordingly. So like if I don't know, player is jumping or is moving and can give signals to other nodes. Delegation mechanism built in Godot that allows one game object to react to change. Exactly what I was saying. Using signals limits coupling and keeps your code flexible. Coupling. Yeah, basically having the same two nodes that acting the same way. Degree the interdependence between some modules. Got it. This we do not need to know right now. As mentioned in the introduction, signals are Godot's version of the observer partner. Yeah, I will learn about it maybe other time. We'll now use a signal from the previous lesson, listening to player input. So, add a button to our game. We'll create a new scene. We'll include both a button and the sprite 2D we created using the creating first script. So, new scene, new node 2D. We have to add another node to a sibling, the button. Okay, so the button UI actually very intuitive. The scene tree, then we save as a node. In the node tab here, we can find signals that they can emit. If the frame changes, if the texture changes, if it is ready, if it is hidden, if it is drawn. Now for the tutorial I think they created another thing. Oh, it's a sprite 2D. But we need to listen for the button to be pressed. Double click the press signal to open the node connection window. And then here we can connect the signal to the sprite 2D. The node is a receiver method, a function that Godot will call when the button emits the signal. The editor generates one for you. By convention, we name these callbacks methods on with an underscore, node name signal name. So here will be on button pressed. Probably the name, literally the name of the node. When connecting signals with the editor, you can use two modes. The simple one only allows you to connect the two nodes that have a script attached to them and creates a new callback function to them. The advanced view lets you connect to any node and any built-in function, add arguments to the callback, and set options. You can toggle the mode in the window bottom right. Okay. Interesting. Click the connect and it creates a new function where we can use basically the code. If you click this icon in here, we see the connection. So our sprite moves thanks to code in the process function. Godot provides a method to toggle processing on and off. Node set process. Another method of the node class is processing returns true if idle processing is active. We can use the not keyword to invert the value. So when we press the button, set process not okay. So basically you are enabling or disabling the processing. Interesting. So I can disable whole process functions. That's actually very interesting. I don't know at the moment how can I use it to the fullest, but something that we'll need to keep in mind. Basically you are choosing what to update and what not. It could be useful for scene management. Maybe I load, but anyway scenes are already different nodes, so I could just load another node if I want to change the scene. I don't know. It just need to know that I can do that. The function will toggle. Okay, before trying the game, we need to simplify our process function to move the node automatically and not wait for user input. Yeah, we basically are back to the previous code. And you can complete, okay, your complete code should be looking like this. Okay, and you can connect signals. We already finished. Well, let's just read a couple of minutes of this page just to complete this section here. So you can connect signals via code. Here we have a timer. They basically, I think, of course, will be auto start, and we need to do two operations: get the reference of the timer and call the connect. Connect a signal via code. We want to connect the signal. So we need a reference to the timer and we need to call the connect method. So reference is the get node. I think it is the same also to using the dollar symbol. And here it is using the ready function. I mean, why before we are using init and now we're using ready? That's actually, I don't think I missed something. It's actually not explained here, at least. So we use the get node, and then on node name, which on this timeout, which I think it is the signal, and then we connect the on timer timeout. So this is without the editor, and then we create our function on timer timeout. I think it's more complicated. You see, now it is ready here. It's not init anymore. I mean, did we use init here? No, we didn't. But he was talking about using init before. I don't know. I see more often the use of ready, so I will stick with ready. Okay, when we have custom signals. Okay, custom signals I can maybe keep it for another episode. All right, we went through another part of the manual, and I think I'm starting to get a little bit on what are the main functions that we'll be using, like 90% of the time, since they are the bricks that compose the most parts of the game, and the rest is basically game logic. As long as I learn how to, create nodes, expand, update nodes, remove nodes, how to view and change the property that I need, I think that very soon I will be able to be more focused on actually making the game and not learning the engine. But anyway, that's it for today's episode. As always, sorry if these episodes are very boring to watch, but as I continue to say, the scope of these devlogs that I called POMODEV is to code and learn in real time. And that's mainly also for me to get back to the process. Maybe in the future I will start to do some summaries and something more entertaining than this, but I still hope that someone can see behind the curtains of developing, since many talented video makers and developers sometimes are making the devlogs look like more fun than in reality is. Not that this isn't fun, but it's, it's like the heavy stuff you need to do before having the freedom to actually make your game. So anyways, enough rambling. See you in the next episode. Take care.